Welcome to the Data Structures and Algorithms course of the Department of Computing, Mathematical and Statistical Sciences in the School of Science at the University of Namibia. This course is offered in semester 1 of 2024. Your instructor is Mekaona Mufeti, an associate professor in the School of Science. My office number is 210 and my contact details are indicated on the slide. Yes, I am a graduate of computer science and physics here at the University of Namibia. I also have an honors and a master's of science in computer science from Rhodes University, as well as a PhD in information systems. The course code is COS 3711 and the title is Data Structures and Algorithms. Like all other UNAM full courses, we require 4 hours of teaching for the semester. Our timetable is Tuesday at 15:30, Wednesday 16:30, Thursday at 15:30, and Friday at 15:30. We'll also have a 3-hour supervised practical session every week, which is proposed for Thursday 9:30 to 12:30 in the third year lab. The course has 16 credits. It's a third year course, so NQF level 7, and you must have passed object-oriented programming 2 before you register for this course. So how are we defining data structures? These are simply mechanisms that we'll be using to store and organize data in our computer applications. It's important that we understand how to store data because efficient data organization will make it easy for us to retrieve and manipulate that data later. Also, data structures will form the basis for choosing appropriate algorithms for our application. Algorithms, on the other hand, are step-by-step procedures that we follow when we are solving problems. They provide a systematic approach that should be followed when we are solving a computational problem. You can have an algorithm that operates on various data structures, but it's important to note that some algorithms will not work on all data structures. So why study data structures and algorithms? Firstly, it's because we want to develop efficient software, and this requires efficient choice as well as use of data structures and algorithms. Secondly, we want our software to make an impact in terms of its correctness, its performance, its scalability, as well as maintainability. When we are developing software, we also need critical thinking as well as problem-solving skills. Studies of data structures and algorithms enable us to develop these fundamental skills. Let us now dive into the real-world impact of data structures and algorithms. It's important for you to realize that these fundamental concepts are not just theoretical, but that they play a crucial role in shaping the way that we use technology every day. The first example is that of social media algorithms, where these algorithms are used in your favorite social media platforms to provide personalized content recommendations. So for example, friend suggestions, and they also use sophisticated data structures to analyze the user behavior as well as to provide a tailored user experience. Example 2 is of navigation systems, where we have GPS navigation systems that rely heavily on the use of algorithms to find the most efficient route from one point to the other. So the data structure that can be used in this case is a graph data structure to represent, for example, a road network. Then you can use an algorithm such as the Dijkstra's algorithm to employ optimal path finding. Example 3 is that of recommendation engines. We have online shopping platforms as well as streaming services that use recommendation engines powered by complex algorithms. The algorithms are used to analyze user preferences and behavior and to suggest appropriate products or contents, and thereby enhancing the engagement of the user. Example 4 is that of search engines. Google search engine, for example, uses intricate algorithms to provide relevant search results. So in this case, a data structure that is used might be an invented index that will help to efficiently retrieve information from vast data sets, thereby demonstrating the importance of speed and accuracy. In the last example, we are looking at financial algorithms that are used in the financial sector, and they are employed for high frequency trading, for risk assessment, as well as for fraud detections. The applications that are used in this case require robust data structures and efficient algorithms because they need to process large volumes of data and they need to do so in real time. So it's important for you to note then that real world applications show the omnipresence of data structures and algorithms in our digital experiences. They also assist us in decision-making processes, and they improve overall efficiency in various industries. So you must understand these concepts because they are essential for building intelligent and effective software systems. So what are we hoping that you will be able to achieve, or the general objectives for teaching this course? Firstly, we want you to understand the fundamentals of data structures and algorithms. We want you to know what those fundamental data structures are, as well as the fundamental algorithms, as well as how to use them. We want you to be able to analyze and to design efficient algorithms that are appropriate for the specific problem that you are solving. We also want you to acquire knowledge that is essential for you to solve problems in real-world scenarios. Then we move to the specific exit learning outcomes of the course. Of course, they are related to the general outcomes. We want you to be able to implement elementary data structures. So these elementary data structures include arrays, linked lists, stacks, and queues. You must understand the nuances of choosing the right data structure based on the specific use case. We also want you to know the basic sorting as well as searching algorithms, and you should be able to implement them as well as to apply them. The basic sorting algorithms that we will discuss include insertion sort, bubble sort, selection sort. We will also look at other algorithms such as quick sort, merge sort, and shell sort. But we also want you to know the searching algorithms, including linear search and binary search. You should also be able to recognize where each algorithm is applicable or is most effective from a given scenario. Then you must be able to determine an appropriate algorithmic approach to a problem. So when you are given a problem, you should be able to analyze it and determine the most suitable algorithmic approach. So will you be using brute force, a greedy approach, or divide and conquer? Then once you know these approaches, you must also be able to apply them to solve the problems efficiently. Very important, you should be able to determine and explain the time complexities of different algorithms, because it is possible that a specific solution can be solved with one or with two or more algorithms. So how do you determine the time complexities of various algorithms, and how do you compare and choose the most informed or the most appropriate algorithm choice? You must be able to determine as well as to discuss the runtime and memory requirements of an algorithm. So given a principal algorithm, how do you know how much time and how much memory it will require? What trade-offs do you need to make in terms of time versus space complexity? Then we want you to be able to solve problems using fundamental graph algorithms. So of course you should be able to implement and apply essential graph algorithms, including breadth first search and depth first search. And then you should be able to apply them also to solve real world problems in diverse domains. Then you should be able to determine an appropriate problem-solving strategy. As I already indicated, we have several approaches, including brute force, greedy, dynamic, as well as divide and conquer. So you need to develop an intuition for selecting the most effective strategy when you are given a specific problem. Then you need to be able to evaluate algorithmic solutions. When you have multiple algorithmic solutions to a problem, how do you justify and give reasoning for your choice? When you have selected a particular algorithm for a specific context, you need to be able to give the reason, well-justified reason for your selection. On this slide, we look at the historical perspective of the development of data structures and algorithms so that you have an appreciation of the intellectual journey that has shaped modern computing. So we will discuss key milestones as well as influential figures that have paved the way for our current understanding. We start with the Alan Turing machine, which was introduced in 1936, which is a groundbreaking concept that laid the foundation for the theory of computing. So it introduced the notion of algorithms, computation, as well as the theoretical limits of what can be computed. Secondly, we look at the von Neumann computer architecture, which was introduced by John von Neumann in 1945. It's basically an architectural design that specifies how electronic computers process and store data. And it influenced the development of modern programming languages, emphasizing the separation of program and data storage. In 1952, Grace Hopper introduced the A to 0 system, which marked the birth of the compiler, and it also enabled programmers to use symbolic code rather than machine language. This innovation significantly enhanced the efficiency as well as the accessibility of programming, because now we do not need to learn machine language for us to be able to write computer programs. Then in 1968, Donald Knuth introduced the art of computer programming, which is a seminal work that laid the groundwork for the systematic study of algorithms. Today, this seminal work remains a cornerstone of computer science education. Continuing, we are looking at Dijkstra's algorithm, which was introduced in 1956 for finding the shortest path in a graph. This algorithm exemplifies the practical applications of algorithms, and it plays a crucial role in networking and transportation planning. In 1976, we also acknowledge the work of Paul Bachmann as well as Edmond Landau. These two gentlemen introduced the Big O notation, which provides a standardized way in which to express algorithmic complexity. So it enables us to compare and analyze the efficiency of different algorithms. Then, of course, moving to the 1970s to the 1980s, this is where the programming paradigm known as object-oriented programming was introduced. Then the development of OOP languages such as Smalltalk, C++ influenced how data structures were also conceptualized and implemented. So this paradigm, it was a shift that facilitated modular and scalable software development. We continue to navigate the intricate landscape of data structures and algorithms to look at how and where they are used within the software development life cycle. So we will look at each foundational phase and look at how data structures and algorithms have shaped the trajectory of software development. Let's look at problem analysis, where the developer or software developer needs to assess the nature of the problem at hand. And at this point, data structures will allow the software developer to make informed decisions regarding what data structures and algorithms are appropriate and which ones will best address the specific requirements that are identified under problem analysis. Then we look at the design phase, where architects and developers need to develop a blueprint for the software structure. Here, data structures and algorithms will influence the overall system architecture and set the stage for efficient processing and storage. At the implementation stage, this is where we code or we craft the code that is based on the chosen design. In terms of data structures, here we make sure that we create robust, scalable, and maintainable code. Under testing and debugging, we need to test the efficiency of the chosen algorithms and scrutinize them under different scenarios. And it is at this stage with data structures and algorithms where we may need to optimize or to identify areas that require optimizations and adjustments so that we can enhance the overall stability of the system. In the deployment stage of the software, we need to make considerations about the efficiency of data retrieval as well as the execution or computational speed of our software. When we are doing maintenance and update, we also need to keep optimizing the existing functionalities. So we need to make improvements, but at the same time, we may need to make sure that we do not compromise the integrity of the software. Then we have scalability planning, where we need to scale our software so that it can match the increases in user base volumes as well as data volumes. Here, it's important to note that good data structures and algorithm choices that were made in earlier stages of the life cycle will allow seamless scalability. A quick overview of the course, of the topics that are covered in the course. For the data structures, we will look at elementary data structures such as arrays, stacks, queues, linked lists, trees, hash tables, heaps, and graphs. For the algorithms, we'll look at searching algorithms, including linear and binary search, depth-first search, breadth-first search. Then we will look at sorting algorithms, including bubble sort, selection sort, insertion sort, merge sort, quick sort, radix sort, as well as shell sort. For the algorithm design approaches and techniques, we will look at divide and conquer, recursion, dynamic programming, backtracking technique, brute force, as well as graph algorithms. We will conclude the course by looking at computational intractability. Prerequisites and assumptions. You have passed object-oriented programming 2. So I will assume that you have the foundational understanding of programming concepts and that you are at least proficient in Java or C#. Mathematical basics. You must have a basic understanding of mathematical concepts such as logic and algebra. Algorithmic thinking. You should be familiar with problem decomposition and step-by-step solution development. So you should be able to break down a complex problem into smaller components and to understand the different types of logic. Then you should also have covered basic data structure fundamentals, especially understanding of arrays and how data can be organized and manipulated in an application. Then we are going to develop critical thinking skills, but at this point you should already be able to analyze problems and design solutions. So your ability to approach problem solving with a logical and analytical mindset is essential. Then of course you should be curious and open-minded. You must be willing to explore new concepts and problem-solving techniques. So you should be open to challenging yourself and to engage in the iterative process of learning. The methodology that will be used to present the course is as follows. We will have 4 lectures per week. where we'll have traditional lectures covering the foundational theories, the key concepts, as well as algorithmic principles. Then we have a 1 hour or 3 hour coding session every week, where we will reinforce the theoretical concepts through hands-on implementation. Throughout, we'll be looking at case studies and applications, where we have real-world case studies that will illustrate how data structures and algorithms are used in the real world. We'll also have code reviews and optimization, where I will ask you to analyze the code, identify optimizations, and discuss best practices for efficient solutions. Hopefully, we can also have problem-based learning, where we can have collaborative projects, the way you will work with others to apply comprehensive knowledge to real-world challenges. In terms of course resources, the prescribed book for this course is Data Structures and Algorithms in Java, published by SAMS Publishing and written by Robert Lafor. It's a 2003 publication, but still very much valid for today. Recommended reading additional resources is an Introduction to Algorithms book by Coleman, Stein, Rivest, and Leisterson. This one was published in 2001. The course will be assessed as follows. We have continuous assessment that will make up 50% and exams 50% to give a total of 100%. For continuous assessment, we will write 3 class tests that will contribute 60% and 3 practical assignments rather, to contribute 40%. So for the tests, they will be written in week 4, 9, and 13, while the practical assignments are due in week 5, week 10, and week 14. In terms of Rule 7.14 of the General Rules and Regulations of the university, it's important that you at least have 80% lecture attendance and 40% continuous assessment marks before you can be admitted into exams. So this means that I will be taking attendance at each and every lecture. If you are not able to attend, whether it's a lecture or it's a continuous assessment mark, it's important that you complete the necessary application form that you can obtain from the office of the registrar and provide the necessary documentation in advance. If you miss especially an assessment component, it's your responsibility to make sure that you have made the necessary arrangements to catch up, and also make sure that you have the necessary approvals beforehand. Academic dishonesty. You know that universities worldwide are grappling with academic integrity. So we need to protect our reputation, and therefore we will uphold strictly the policies and principles that are specified in UNAM's plagiarism policy. It does not condone any form of academic dishonesty, which includes plagiarism, cheating in assignments and tests, as well as other such practices. Therefore, please make sure that you do your own assignments, that you produce your own academic work, unless if it has been specifically indicated that it is a group assessment task. You need to familiarize yourself with the UNAM's plagiarism policy, and it is available on the UNAM website. Thank you. This is the end of this session.